Hi, welcome to the channel, Budget Audio Review and Upgrades. Now today I'm going to be talking about this little Nobsound 6P1 amplifier I bought from China. Well, actually bought it from England, but obviously come from China. A cheap entry-level valve, fully valve amplifier, the preamps valve and the actual main amplifier's valve, not like some of them you can get where the preamplifier may be valve and it's got a little IC or something like that in it for the actual main output. So just be wary of that. There is a few out there that you see they've got valves on top, they have 3 or 4 valves on top and you think, well, that's a valve one, but inside it's still got a little IC or something like that. I mean, it's fine if you're looking for something like that, but don't think you're getting a fully valve one. If you're expecting a full valve one, you could come unstuck. There's a few kind of people call them fake ones or something like that. Anyway, today I'm going to be talking about the power supply, the adjustments or the modifications I did to my power supply. Now, near enough all these modifications I did, apart from one or maybe two, is that I followed a YouTuber called Skunky Design Electronics, and she kind of like not so much recommended this amplifier, but said it wasn't a bad amplifier once a few adjustments were made here and there. And I thought that would give me something to tinker around with. Been interested in maybe getting a tube amplifier, see what they sound like, get an idea what a tube sound is. I had an old radiogram many years ago that my granddad gave me, I think. Can't remember how that actually sounded, and don't forget it's an old kind of radiogram thing anyway, but never really had a valve amplifier going through some decent speakers, so to speak, to actually listen to and kind of get an idea how it sounded. So I thought this would be like an entry level. Wasn't expecting too much, I suppose, for the £300 or thereabouts that I paid. And I don't know, if you're paying that kind of money, you're probably not going to get anything fantastic, that's for certain. But it may give you a kind of like a dip in the water, so to speak, of these valve amplifiers sound. Now, this amplifier come to me, like I say, I follow Skunky, and on that channel she said that the actual transformer inside, it may not give out the correct voltages going to certain parts of the circuit, and i.e. the tubes may go a bit quicker than they should do, maybe putting a bit too much stress on them tubes, etc. She also done a few other little modifications to help the sound, to give it a little bit more headroom, to make it sound a little bit nicer. So I thought, well, I'll do them as well. But I'll come to that in another video. Just really going to concentrate on the power supply part of it here, because there's just a few things to bear in mind. It doesn't matter if you're buying this in the US, in the UK, or any other country really. It's just a few things you should bear in mind when getting this, that the transformer they use inside may not be giving the correct voltages going to certain parts of the amplifier. So in her video, she's done a few alterations, a few mods, a few swap outs here and there to kind of bring it in line to hopefully get it working correctly, sounding better, etc. The first thing she did was change a 150 microfarad capacitor to a 22. Now in my one I did that, but I was getting a little bit more of a hum than I was getting before. So I made that a 47 microfarad capacitor instead, brought the hum back down to where it was before, and that was more acceptable for me. It's just a little bit of hum on it. You notice when you put your ears right up against the speaker. But changing that capacitor to a 22, you kind of heard it without putting your ears so close to the speaker. So I just wanted to get back in line to where it was when I first bought it, should I say. Plus you've done a bleed resistor across the capacitor, the 150 microfarad, down to earth. I think it's a 470k 2-watt. So just when you turned it off and you started tinkering around inside, that should bleed the capacitors down, discharge them, and you shouldn't be getting any electric shocks. But be very careful when doing any of these mods. But like I say, I just want to bring this to your attention because you may want to get this and do no mods whatsoever. There is a couple of things you can do to do that. I'm not saying the one you're going to go and buy is going to be like too much voltage where it shouldn't be. On the anode mainly of the 6P1 driver, the main output valve, should I say, that voltage on the anode should be 250 volts or less, and on my particular unit it was reading 279. Was it reading 279? Yeah, somewhere around there anyway. So that was too much, 275 I think actually, but somewhere around there. So it was too much, and obviously would knock that valve out a bit quicker than it should do. So there's a couple of ways around this. You could buy yourself a little auto transformer. There's a picture on the screen now. This is a little transformer for me in the UK only, this is, which knocks down, my voltage here is between 238 and 241, and that knocks it down to around about 225 volts. So it goes in at 240, comes out at 225. So that brings the voltages inside the unit down to a reasonable level, to where nearly they should be. Trouble is, they weren't quite right on my particular amplifier. I was getting the anode voltage. I measured to the anode voltage, sorry. I'm trying to get it out as quick as possible. I'd speak fast and try and get it out so you're not here all day listening to me rabbiting on, and I kind of like go a bit too fast sometimes. But anyway, going back to that, the anode voltage on the output valve was 252 volts. We really want it less than 250. So it was near enough, just 2 volts over, so that was acceptable kind of thing. The only problem is putting that transformer, that little auto transformer, did bring the ether voltages down from 6.3 down to about 5.7, 5.75. Now, reading a few things, it's kind of like some people say these valves can run on 5.7 volts, the ethers that is, and it may even prolong the life of the valve. It's a bit up in the air. Some people seem to agree with it and some people didn't. So I thought it'd be good if I can just get the valves ethers to 6.3 volts, something I wanted to do, even though I brought the rest of the voltage down. And I've still got this little auto transformer sticking out. I've got to put it somewhere to use this amplifier. I've got to have this little transformer on the side or somewhere else in the way. If I can get rid of that completely, that'd be good. Another thing you can do is buy this thing. It's called, I'll put a picture up on the screen, called a Line R1200. This is like a mains kind of filter in a way, but also a regulator. This will regulate the mains here in the UK. Now they do them for America as well, but here in the UK it's 240 volts in. I think they call it 230 or 240, something like that. But you've got a little switch in the back. If we turn it over to the back of it, that little switch I think gives out, depending where you put it, gives out 210, 220 or 230. So you can bring it down to the voltage probably around about 220, something like that this particular unit would like, and it would give the correct voltages going to the anode. But we still got that problem with the ethers, where if 220 is going in, it's probably going to bring the ethers down to about 5.6 volts. So we're getting really borderline now. So there is a way, it kind of works, and it don't kind of work, if you know what I mean. It kind of corrects one voltage somewhere, but doesn't correct the voltage somewhere else. It's kind of like a scales, and we want to get it balanced a bit more nearer, really. So I thought, well, it's another way of doing this is actually to put a resistor in the circuit, a fairly high wattage resistor, so it doesn't eat up too much, just to bring the voltages down to the correct level. So that's what I've done in my particular case here with this amplifier. Now, you may want to try this yourself. I'm going to show you in this video where to measure the voltages from, the critical kind of voltages. You may or may not want to do that. Like I say, you may just want to leave it as is. You think, oh, I've got too many volts going here. I'm not too worried. If the valve goes a bit earlier than it should do, it's not the end of the world. I'll just buy another set of valves. I mean, it's entirely up to you. Obviously, you bought the item. It's your choice. But for my particular item, I just wanted to try and get all the voltages running correctly, should I say. Didn't want to use these transformers and mains filters on the outside and all that, where it's dropping the ether voltage as well. There's another unit to have next to it and all that. It's kind of getting a bit more cumbersome. So putting that resistor in a place where it just drops down the I voltage, but also keeps the ethers exactly where they should be. And my ethers measured 6.2, 6.3 without adding these auto transformers or these main suppressors down. So they're near enough bang on, and I wanted to keep them that way. So I'm going to show you a little video now of exactly what I did, and we'll come back to me just for a final summarise. Right, I will put a picture up on the screen as well, and hopefully you can follow me with that picture and the picture I've got up on the screen here. Just going to go through a few things here, but we'll put some stills up, and hopefully you're going to get the gist of what I'm trying to say here, and point out this is probably the only way I can do it, really. Right, this is my amplifier before. As you can see, the mains voltage here in the UK is around 240 volts. Mine seems to fluctuate between 238 and 241. What I was finding is that I was getting these voltages here, these test points, 297 straight after this valve rectifier, 288 after this choke. I will show you where to take these readings from shortly, and 279 here. And these voltages here a bit too high. If we have a look at Skunky's voltages, and so just put it up here very shortly, you'll see that these are a bit on the high side. The main one being this one at the top here, the anode of the output valve here, or output valves, is 276 volts DC it measures, and them valves have a maximum voltage of 250 volts to the anode. So 26 volts too much going there. Just want to draw your attention to a couple of other things here. This circuit actually splits here. This is like just one circuit here in the power supply. As soon as it gets to this point here, this resistor 1.5k and this 22 microfarad capacitor is doubled up. They're in stereo, so you've got one channel there. This supplies one channel to the preamp, which goes up here, and it also supplies the other channel with a separate 1.5k, so just imagine it above maybe, and another capacitor, and they go off and supply the other channel. So it splits just here, the power supply splits into two, but before that it's just one. But at that particular point there, it splits. This capacitor, there's only one capacitor there, but it splits straight afterwards. And also this here, this 288 voltage here, goes up to the output transformer. It drops 12 volts across the output transformer, but it's still too high for the anode at 276 volts. So if we go to the next picture, this is Skunky's power supply, 110 volts there in the US, and this is what Skunky recommends the voltages should be at these certain points. As you compare Skunky's with mine, at this point here, mine's 297, Skunky's is 275. At this point here, mine's 288, Skunky's 265, and here, which goes to the preamp, is 279 on mine and 255 on Skunky's. Now that 265 there, that's the point that goes up through the output transformer and onto the anode. That 265 of Skunky's becomes 250 once it goes through that output transformer, and actually it's the anode of the valve. It comes in at 250 exactly, which is the maximum. So if we go to my next slide, this is what changes I've done to my power supply. As you can see, there's my power supply. Above is before, and below is after I've put a couple of items, a couple of components, should I say, into the circuit. Now, first thing I'm going to do is I'm going to leave a link to Skunky, a way she actually did this, so you can follow that video. She changed this capacitor here, which was a 150 microfarad capacitor, to a 22 microfarad on her circuit, but I've changed it to a 47. I did try a 22, and I found it's just a bit too much for me. It kind of brought up the I changed it back to a 47, which is still 100 less than the original 150, and that kept the as it was. It didn't increase it, it didn't decrease it, where the 22 microfarad did. Straight after coming out the rectifier valve and connected also up to this capacitor, so to speak, is I put a 350 ohm resistor in series there to the choke. So I disconnected the choke, put a resistor in series to that point. I'll show you that shortly, exactly where I did that. I've got a 50 watt resistor. Actually, I've got two 50 watt resistors. The reason for that is you don't need them that high. You're probably going to get away with a 20 watt resistor, something like that. But I've got two 50 watt resistors, 100 watts. They get lukewarm now, so it's hardly any heat coming off of them at all. Obviously, if you lower that resistor wattage, you're going to get more heat. And I've bolted mine to the chassis, and I just want it to run fairly cool. So I've put some big chunky ones. There's plenty of room. You won't need, you'll see in a minute, I've actually used two resistors here, a 150 ohm and a 200 ohm as well, because I was like tinkering around, experimenting. But I would suggest that you use a 330 ohm resistor there, and use 50 watts that way. Like I say, it'll run lukewarm, just a little bit, a little bit on the warm side, just a little bit. Goes through the choke, and I've done that bleed resistor there. That's in the video down below that Skunky did. Little 2 watt 470k bleed resistor down to ground. Just when you unplug the unit and you start doing all this, it actually drains the capacitors of any voltage. Don't take long, takes about 6 or 7 seconds, something like that, but it will drain the capacitors. So when you go to work on them, they should be discharged. But double check. You may want to short them out yourself. Well, I say short them out, you may want to use a capacitor discharger yourself on them, just to be on the safe side and measure the voltages, etc. And just after that, I've changed the 1.5k resistor to a 1k 2 watt resistor. This is a 2 watt. I've changed it to a 1k just to increase this voltage here, because it dropped down a little bit. It dropped down to about 245, I think. Changing that to a 1k knocks it back up to 250. So if we look here against Skunky's actual circuit, so if we go to mine versus Skunky's now, as you can see, the voltages here, 275 for Skunky at the top, mine's 297, but this is where it changes here. I've managed to bring the 297 down to 255 volts here, 10 volts less than Skunky. So on my anode now, I'm getting a roughly 241, 242 volts on that output tube on the anode. So I'm about 8 volts less than Skunky, at that particular point, but that's okay. So like 255 versus 265 are skunky, so I'm near enough. I'm only 10 volts out. If you put a 330 ohm resistor there, that's going to bring it bang on, near enough, exactly the same. And where Skunky's got 255 going to the preamp, mine's 250. Like I say, if you change that, didn't have the two resistors like I've got, and had a 330 ohm resistor, that voltage will probably be about 255 as well. So pretty much match up exactly. But I've left mine now. I've got the two resistors here. I'm not going to worry about an odd 5 volts here and there. So if we go to the next slide here, this is where we measure the voltages from. Now be very, very careful. Obviously these voltages can kill you, so my voltage is here, so be very, very careful. But if you've done this adjustment already, where you've put this resistor in here, this bleed resistor, which is this resistor here, if you've already done that and changed this capacitor here, which is this capacitor here, following Skunky, then this should bleed itself down as you work on it. It should bleed, and these should be discharged about 8 seconds, something like that. But if you're going in there first time, make sure you turn it off and you put a bleed resistor or something across the positive and negatives of these capacitors just to discharge them. So yeah, here's the voltage. So we're going to take your negative of your meter and go to this point here. I'll put it up on the screen, hopefully you can see that. The 297 voltage that I measured gets measured from here. You put your positive of your meter there. If you want to measure the 255 voltage, shall I say, here, it goes to that point there. And if you want to measure the 250 volts here, going to the preamp, that gets measured, should I say, from there. So that's where you measure your voltages from. Don't forget, that's the negative for your meter. On the DC range, 1000 volts, something like that, put your meter on. Negative there, and these are the positive, where you put the positive for the meter to get the positive voltages. Right, if we go on. Now that resistor, if I just come back, that resistor there, and mine at 350 ohm, I suggest you just use one resistor, but measure these voltages just to make sure they're kind of in line what they should be, kind of thing. You may just have to tinker around with that resistor just a little bit. But anyway, if we go over to how I've actually put that resistor in, that 350 ohm resistor, it comprises of two resistors. There they are, a 200 ohm and 150 ohm. Now this choke here, normally if you open your one up, a wire, this red wire here, if you can see it, mark number 1, would normally go up to 0.2. It'd be connected to the rectifier valve just there. I've disconnected it. I pulled the wire through. It goes underneath this here. I pulled the wire through. If we follow it, you can't really see it because it gets tucked in behind, but it comes to this side of the resistor here, that connection there, number 3 of resistor 150, 150 ohms. It connects there. That resistor is in series, gets linked up to resistor 200, the 200 ohm resistor. If you follow the wire number 4, you can see it gets linked up. It comes out at the top, number 5, that wire, and if you follow it, the wire's number 6, it goes all the way around and goes to the point 2 where that original wire was connected to the choke. So that, in theory, rather than going straight to there, it's kind of passing them resistors first, then going to there. So that's how the choke's wired up in mine. And I've bolted that choke with 2 screws to the chassis, nice and tight. So it's a little bit of heat, like I say, coming from these resistors, hardly anything at all, but it's get dissipated through the chassis. So that's how mine's wired up. As you can see, I've done some other bits and pieces that may look a bit different to yours, but I'll come to that in another video. But that is how I've wired up my power supply now. These are the 2 resistors I've changed here also, from 1.5k to 1k. So there you go, that's my power supply, how I've actually done it on my unit. Right, so hopefully you kind of got some kind of gist of exactly what I did with my unit. Now that resistor, that 350 ohm, don't forget, you can probably swap that out for a 330, just one resistor, rather than where I've put 2 in series there and taken up a lot more room than I should have done really. Also that resistor can go in one more place as well. It could actually go off where that spur goes to the 2 separate channels, to the output transformers of both channels. You could have actually took it off in both them directions, but this was just an easier place for me to wire it in to show you on the video, and it works well. I've had no problem with it, and the amplifier runs nice. It runs warm. Obviously the valves get hot, but they don't get over hot, you know what I mean. they're a reasonable kind of temperature. They're not getting too hot. Their output transformers, they're running pretty cool, really, to be honest with you. And that main transformer is not, I'll grab hold of it. I mean, I'm not suggesting you do this, but have a good feel of it. Squeeze it quite tight after I've had the unit on 2 or 3 hours, that kind of thing. And it doesn't get excessively hot at all. And then resistors inside, like I say, run pretty much lukewarm, really. Hardly any heat coming off of them because they are both 2 50-watt resistors in series. But yeah, maybe you just want to go for one 50-watt, maybe a 330 ohm. But maybe you want to try them test points, the voltages as well. And you may be able to just, depending on your transformer inside, because these transformers inside the main transformer of this unit, it depends how many windings it's had around it and all that, who's been winding it, if it's machine done, all that kind of stuff, what transformer they've used to start off with. My one's got 240 volts written on it, but who's to say they've just written 240, and that was a 220 volt transformer to start off with. Anyway, hopefully you may have got something out of that if you're thinking about buying one of these Japanese 6P1 Nobsound amplifiers. There may be something to think about also if you're buying any of these Chinese cheap amplifiers, that maybe the voltages inside are not quite where they should be. Anyway, I was saying, I'm going to say a big thank you to Skunky Design Electronics that kind of got me into this amplifier and has showed me how to, through her videos, how to actually change things. And also, like I say, I've done a little bit of experimenting myself, which has been a little bit of fun, a bit frustrating waiting for parts to turn up, etc. But it's been fun along the way. It's just took up a lot of my time in the recent weeks doing this alterations and this video. But anyway, I will come back. I'm going to sound test this again now. I've got some other valves to swap over, so I will do that. And I'll come back with my final thoughts. This was my £300 well invested. Did I waste me money? And generally what I thought about the amplifier. But until then, I'll say thanks for watching, and I'll see you all soon.